All right, if you are in my Calc AB class, then this would be Notes 26 for you. If you were in Calc BC, this might be one of the first things that you do in BC. I don't really know. If you are in Calc 1 in college, this might be very late Calc 1. It might be very early Calc 2. I don't know. We're all over the place. Actually, if you take a traditional BC class, this is probably late in the year for you. I don't really know. Okay, so integration by parts. Essentially, we're going to talk about how you can reverse the product rule, right? So we know U substitution, we know things that we memorized, but there's a lot of things that finding the antiderivative of is like very challenging. So let's learn another technique for things that we can integrate, but that aren't as obvious. So it's pretty straightforward once you get the hang of it, but until you get the hang of it, it's pretty crazy. So we start with just the product rule, right? And what we're going to do is we're going to rearrange the product rule a little bit. So what I'm going to do is I'm actually going to, I'm going to subtract, what am I going to do? I want to, oh, I got it. Don't even worry about it. Here we go. I'm going to say it's d dx of u times v. U and v are both functions of x. So like one of them might be x cubed and the other could be sine of x or something like that. So they're both functions of x. I'm going to subtract vu prime from both sides and say that's u v prime. Okay, so like what does this get me? It kind of gets me nowhere, but what I'm going to do now is I'm going to put in integral signs like all over the place. And here, this is not really a formal way of doing this, by the way, because once you know the formula, it's like no one really cares. So here I'm going to think about this, right? So if I integrate, so for the first, I'm looking at this part right here, right? If I integrate, let's shade the whole thing. Okay, so if I integrate the derivative, it's just going to take me back to the original. So this part here should take me back to u times v, and then minus the integral of v. And then what I'm going to do is I'm going to replace some things here. So u prime, I'm going to call du. So v du is equal to the integral of u, and I'm going to do the same thing for v prime. I'm going to call v prime dv, because I like that notation better. So let's say it's dv. Okay, so then how is this helpful? It's not obvious that this is helpful at all, but I'm going to rearrange it so that it looks like a little more famous. Actually, it's already written down here, sort of. So you rearrange it and you say that the integral of u dv is equal to uv minus the integral of v du. This is not something, so this derivation, if I had to guess, is probably not something that you care about, although you could come up with it at any time. I should use a thicker highlighter. I'm pretty sure everyone is probably thinking that. This is the formula that we're going to use. So how is it going to work? Well, we're going to make judicious choices, right? So we're going to start with this, and we're going to pick what we think u is and what we think dv is. And then we're going to look, also it's really annoying, it's just like with vectors, you use u and v, like could you pick things that look more similar? So we pick u, we pick dv, look at the formula. So I'm going to need to know what v is, so I'll have to integrate dv. I'm going to need to know what du is, so I'm going to have to find the derivative of u. But if I can do that, then I might be able to use integration by parts. So integration by parts, generically, so let's put a box around this. Let's use a much larger highlighter so I don't have to highlight for the next hour. Is this. So this is our formula. Okay. So until you do problems, it kind of like doesn't really mean anything. But here's what you do. You make a choice for u, you don't make a choice for dv, actually. You make a choice for u, everything else is dv. Or perhaps you pick dv and everything else is u. We'll talk about how we choose these things, but basically when you make a choice for u, you need to be able to take the derivative of it. But you can take the derivative of anything. Excuse me. So that's not really the complicated part. you pick dv, you need to be able to integrate that. So if you can't integrate what you think dv is, then you can't do it. So then you make different choices, and if the different choices work, they work. If they don't work, it might be a different type of problem. So let's actually do one and see how it goes. All right, so when I see problems like this, I generally speaking will try to pick a u, so that if I had to take the derivative multiple times, eventually it would go away. You want the derivative of u to get simpler also. Also, you need to be able to actually integrate dv. So let's make our choices. I'll go out of my mind here, but I'm going to try like 2 different colors here. So I'm going to say that u is equal to x. And then if I make u equal to x, everything that's left will be dv. So dv must be cosine of x dx. I usually forget that dx. No harm, no foul. All right, I need to find du. So du is just dx. And then I need to find v. So v is the antiderivative of cosine, which is sine. Okay. Don't worry about plus c on these until like the very end. All right, so the formula for integration by parts tells me that the integral of x cosine of x dx should be equal to u times v, so x sine of x. I wish there was so the app that I'm using here doesn't let you have like 2 pens chosen at any one time. That would be an awesome feature. So uv, and then minus, so this is important, minus the integral of v du, which in this case is sine of x dx. And this is like driving me insane to keep switching these. Sine of x, and then I'm gonna, okay, so it's sine of x dx. Okay, so it's uv minus integral of v du. So one of my students one year, or a bunch of my students, they decided to remember this as, this is sort of, it's not really inappropriate, but I also think it's not sound medical advice. Ultraviolet gets rid of venereal disease, like UV minus VD, venereal disease. I don't know if they call it that anymore, like STIs or whatever they are now. I'm not a health teacher, obviously. All right, so I'm gonna go back to one color here and finish this. So it's UV minus the integral of V du equals, so x sine of x minus, what is the integral of sine? It's negative cosine, and then plus c, that's where you put in your plus c. So x sine of x plus cosine of x, and then plus c. And that's our answer. So if we were to integrate, rather, if we were to take the derivative of this, the derivative of this ultimately will clean up into x times cosine of x. Let's check it on the calculator just to be sure. And if it's not right, I'll fix it. And if I have to fix it and it takes forever, I'll probably just scrap this video and try again. All right, let's see. So calculator, integral of x times cosine of x with respect to x. So we get x sine of x plus cosine of x. Calculator doesn't put in plus c, which we all know. So let's go back to the notes. So we got it. So you have to be able to choose u so that you can find derivatives. Basically, if there's a polynomial, you almost always want to make that equal u, because if you have to use this over and over again, you want the derivative to keep getting simpler. As long as that's happening, you're good. The real challenge is that you have to be able to integrate dv, which often is like the reason that I make the choices that I make. So pick u so that the derivatives get simpler. So this is kind of like, let me highlight it. Let me go back to a reasonable sized highlighter. So I usually will pick u so the derivatives get simpler. I am aware that that is not the proper gets. Like, what is that even? Get us, I guess, is what that is short for. But the real key is that you have to be able to integrate dv. And if you can't do that, you're in trouble. Now, there is a thing that some people use. I don't use it, honestly, because I cannot remember it. But some people remember this, liate, for making the choice of u. I don't really know. It's like your order of preference would be logs, inverse trig, algebraic, trig functions, and then exponentials. I don't use it because I can't remember it. But We're done with the first example, so what I'm going to do is cut this video here. I'll come back in the next video and we will keep going. So this is integration by parts. It's in the BC curriculum. It's what we do after the AP exam in Calc AB. I will see you in the next video.